All right, here is our second lesson. This one's 8.7. 8.7 is just a little different than the one before because it just kind of takes a step up. It's all about this guy right here, the A. In 8.6, you had A always equaling 1. But now we have 8.6, in 8.7, we're going to make that not just 1, but maybe a 4 or a 5 or any other numbers. When you're doing this, you're going to end up having numbers that are here that include your variable, but also might include a constant like 4 or 7. So you might get something like 5x and x plus 2 minus 3. That would be one example. It's not just an x by itself. Okay, so there's a method to figuring out how these work. You can sit here and guess and check, and that's fine. Or there's a method that usually works pretty nicely. So I'm going to give you an example. And this is called the M and P method. They don't necessarily call it the M and P method. It just, they use an M and P in the textbook, so that's why I call it the M and P method. It's just a form of grouping is really what it is. We did grouping when we had 4 different polynomial that has 4 different terms in it. And so you end up grouping, but it's a form of grouping that also solves quadratics. Okay, so example 5x squared plus 13x plus 6. This is also one of the problems in the book in the examples that they had you try. So if you want to try it, go for it. But this is number 1A on page 511 if you do want to try it. So I'll give you a second. You can give it a try. And if you want to just pause it while you're doing that, that's fine too. So here we go. So we know that our first numbers have to be, these two things right here must multiply to get 5x squared. So maybe a 5x and an x, or maybe we can put the 5 over here, and that would work too. But this needs to be a 1 and this needs to be a 5, or vice versa. We know that so we have options there. We also have options for our last guy. We know that this part right here must multiply to equal 6. So we could put a 1 and a 6. We could put a 6 and a 1. We could put a 2 and a 3. We could put a 3 and a 2. But we know that it must be positive 6. Well, we could do the negatives of all these as well. So there turns out to be a lot of combinations. We have 1 and 6, and then we have -1 and 6, -6 and -1, -2 and 3. They're all negatives because a negative times a negative is a positive. -2 and 3, and then -3 and -2. Okay, so there's a long list of combinations. And then you would need to try all of those combinations with the 1 and 5 here. And then try all of those combinations again with the 5 and the 1 to see which one ends up, when you do your distributive property, ends up being this. So really there's, let me see, 1, 2, 3, 4, 5, 6, 7, 8. 8, that would be half of them. So there's actually 16 different options that we could try here. Now, if you think about that, that's just, sounds like a waste of time to sit here and try all of those for all of your different for every single problem that you're trying to do. Remember, it's the every other odd problem on your homeworks, not every odd. Some people did every odd, and we just got extra practice. So every other odd. So let's talk about this M and P method. We know that this is our middle guy. So this guy times this guy plus this guy times this guy needs to add up to this 13. Well, we could sit here and guess all day long, or we could use this M and P method. This is what it basically says. Find out what A times C is 30. Okay? if you look at, it's 5 times 6. So 5 times 6 is 30. Okay, so what are the different factors of 30? Well, I could get 1 times 30. I could get 2 times 15. I could get 3 times 10. I could get 5 times 6. Okay, so those are my factors of 30. And then over here, I need them to add up to 13. So basically add up to what b is. Okay. Well, which ones of these can I make add up to 13? Well, this one I can. If I add them together, I could get 13. So this is going to be my guy that I use. Okay. And then at this point, you're going to rewrite original problem and use 3 and 10 instead of 13. And rewrite original problem using factors to break up b. So here's what I mean. We know 3 and 10 are our factors, so I have 5x squared plus, now instead of 13, I'm going to use the 3x and the 10x plus 6. Okay, so really all I did is rewrote 13 this way. Okay. Rewrote 13 with the 3 and the 10. All right, now we have 1, 2, 3, 4. And this is where we're going to use our grouping method. We learned about this already. Okay, I'm going to put these things together with like terms. So I'm going to rearrange these. I notice that the 5 and the 10, or the 5x squared and the 10x squared, have like term, or have common factors within their terms. So I'm going to group them together. And I notice that the 3x and the 6 have like terms. I mean, they have a common factor of 3. So let's put them together. 5x squared plus 10x, parentheses, plus 3x plus 6. Okay, now for each parenthesis, remove whatever that factor is. Well, there's a 5 in both of these, so I can bring out a 5. There's also an x in both of these, so I can remove one x. There's 2 x's here, but only 1 here. So I can only remove 1 out of the entire thing. What's left inside of here? Just an x. And what's left inside of here is just a 2. If I remove the 3 from both of these, because it's the only common factor, I'm left with a 3 on the outside and an x plus 2. Now, how many x plus 2s? If you notice, this guy right here and this guy right here are the same thing, which is what we want. Otherwise, the grouping method isn't going to work. So you got to get the same thing right there, and it'll work out that way, unless you did something wrong. So 5x, so I have 5x plus 5x, x plus 2's, and then over here I have 3x plus 2. So how many do I have total? I have 5x plus 3, x plus 2's. Okay, so these guys get added together, and that's telling us how many x plus 2's we have. So these guys go here, and whatever these are goes here. Okay, then that would be factored form completely. If I lost you anywhere, rewind it, watch it again. One part that I feel like I ran through pretty fast was this part. Okay, this area right here, this is you have to multiply a times c. This is your leading coefficient in front of the x squared term, and this is your coefficient for the c term, which is just, I'm sorry, I should have looked up here. A is this guy, and c is this guy, and then b is that guy. Okay? Make sure that you put this in standard form before you start. Put in standard form before you begin. Get rid of that. And then also, a good rule of thumb is to make the leading coefficient, which is a, positive. And that means you have to multiply the entire thing through all the different terms by a -1. Not a bad idea. But that's only if you are solving. And we aren't solving yet because there's no equal sign. But you'll notice at the end of the section, we will be solving them as well, just like we did in the first lesson. Okay, let's try another one. All right. Okay, so we got that one done. So 2n minus n minus 1. 2n minus n minus 1. Well, first off, let's multiply our a and our c together. Well, what's 2 times a -1? That might be too small. That is a -2. So they need to multiply to get a -2, but add to get, well, what's this term? It's actually a -1. If there's nothing written there, there's a 1. So they need to add to equal a -1. Well, let's look at the factors that get us to -2. We have 1 and 1 times -2. We have -1 times +2. And well, that's it. So when we add any of these two together, we're going to get -1. And here we get a +1. Well, like I said, we want this to be a -1 when we're done. So this is our guy that we're looking for. Okay, now we're going to rewrite this with 4 terms. We're going to break this guy apart into 2 different terms. So 2n plus 1n, okay, so we'll put plus 1n minus 2n minus 1. Okay, so again, all I'm doing with this part is rewriting this part. Okay, I'm just rewriting it. Making it look different, but it's really saying the same thing. So we have 2n. Okay, so can we group these together so that they look alike? Well, these guys look like they go together because they both got, oh, I forgot my squared right here. Squared right there. And I forgot it right there. That's why I didn't have it. Okay, so these guys go together. So 2n squared minus 2n plus, and then these guys go together, n minus 1. All right, so I can pull out a 2 and an n from each of these. 2n, and then I'm left with n, and then I'm left with a, well, 2n divided by 2n just gives me a 1. There's nothing left here except for a 1, because when you divide, if you divide by the same thing, it's going to just eliminate it and make just a 1 left over. Plus n minus 1. Well, you're looking at this saying, well, but nothing got taken out because this one was already done. And you're right. There was nothing left to take out. So, but what's in front right here? If nothing's written, a 1. Okay, and if you look, n minus 1, n minus 1. Okay, well, how many n minus 1s are there? Well, we have 2n of them right here, plus we have 1 n minus 1 right here. Okay, and that's how many n minus 1s we have. And that's your answer. Now, in the homework, let's say they ask you to also solve this for equaling 0. Okay, well, just like we did in the last lesson, 2n plus 1 times n minus 1 equals 0 would mean that you just make this guy equal to 0 and make this guy equal to 0. Because either one are going to solve, or either one, if either one is 0, then it's going to make your entire equation equal to 0. So 2n plus 1 equals 0, and n minus 1 equals 0. So now you just plug and chug. Minus 1, and we get 2n equals -1, divide by 2, and n equals negative 1/2. Okay, so that's 1, and then plus 1 on both sides. We get n equals 1. So those are your two answers if we set this thing equal to 0. Now, those are some of the easier ones. Let's see if we can try something a little bit tougher. Okay, so we got that guy. Okay, example 3. And like I said, all of these are the guided practice in your book. So this next one that we're doing is 2B on page 511. So 10y squared minus 35y plus 30. Okay. So let's see if we can grab these two guys and start our chart. Well, 30 times 10 gets us 300. So we know that this whole section is going to be anything that multiplies to get to 300. I mean, we could do 1 and 300. We could do 2 and 150. We could do, we could do the negatives of those as well. We could do 3 and 100. We could do, I need my calculator. We could do, so 300 divided by 4 and 75, 4 and 75. We could do 300 divided by 5, which is going to be 60. And we're looking for two numbers that could add up to negative 35. So add up to negative 35. So basically, I'm guessing that since this has to be positive, that both these numbers are going to be negative. Because a negative times a negative will get us a positive 300. But we're looking for a negative 35 when they add together. So we're looking for two negatives. Well, if I make these guys negative, it's going to be negative 301. No, we don't want that. Negative 1, so these are negative, so 152. And then negative 3, add right, 103. And then we have negative 79. Again, everything's got to be negative because we need a positive 300. We have a negative 60. How about that? We can add 65. And then we don't have our negative 35, so we got to keep going. So 300 divided by 6 gets us 50. So that gives us a negative 56. That's not it. So 300 divided by 7, I don't think that's going to come out nice, and it doesn't. 300 divided by 8, nope, doesn't. 300 divided by 9, nope. 300 divided by 10, well, I know that's going to be 30 and 10. Okay, so we have negative 10 and 30 and negative 30, but that's going to come out to negative 40. Okay, so when I keep saying nope, that means that every time I try to divide 7, 8, 9 by 300, it's coming out an ugly number, like a decimal or something, because no numbers are ugly. So 300 divided by 11, that's going to come out ugly, but no numbers are ugly. 300 divided by 12, so we have 12 and 25. Okay, so 12 and 25 is going to be negative 12, and negative 25 is going to be 37. Okay, we're getting closer. Let's skip to 15 and see if we get lucky. 300 divided by 15 is 20. 15 and 20. And if we add those guys together, we get negative 35. Ding, ding. Okay, so you should have to look at all the different factors of 300. And you probably, if you started off here, you probably should have noticed we are way far away. Let's see if we can hop down a little bit in the factors and see if we can try some of the other ones before, so we don't have to sit here and lay this whole thing out. And you're probably wishing you had just fast forwarded through all that, huh? So we have negative 35. So we're going to rewrite this thing using negative 15 and 20. So 10y squared minus 15y minus 20y plus 30. Now let's do our grouping method. Let me see. And honestly, there are multiple ways you can do this. You're still going to get the right answer. But let's just say that I'm going to do these two and these two, because they both got things that are in common. So I have a 5 and a y in both of these. So I'm going to factor out a 5y, and I'm left with y minus 3. Nope. 2y minus 3. Because 5 times 2 needs to get me that 10. Okay, and then let's put parentheses. Okay, very important here. Okay, before I jump the gun, let's say that we want to put parentheses around these things, okay? So we have parentheses 10y squared minus 15y parentheses. Now, you have this negative right here, which will mess your problem up if you don't deal with it correctly. If I'm going to pull out something from both of these, then I have to pull it out of both of them. So I need to pull out a 10 from each one of these. We know that. And then it's left with a y, a 2y plus 3. But then what happened with this negative? Well, either that negative stays with this guy or you can pull it out. But if you pull a negative out of this, you better pull a negative out of both of them. So if I pull a negative out of here, it makes this positive and makes this negative. But if we pull it, you basically are dividing each by a -1. Well, it makes this one positive, but then this 30 divided by 1, it makes this guy negative. Okay, what are we going to pull out of here? I'm going to pull out a 5 and a y. So I make this a 5y, and then this becomes 2y, and this becomes a 3. And if you look, these guys are the same thing. So we have our 5y minus 10, parentheses 2y minus 3. Now, I'm not done. This still has a factor inside of it, and that's because I made a mistake at the beginning. And it's a common mistake, but at some point it's going to catch up with you and you're going to have to deal with it. Each one of these, I could have removed something from each one of these at the beginning. I could have removed a 5 and put a 5 on the outside before and made it 5 y squared, 2y squared minus 7y plus 6. And then just factored this. So now I didn't do it at the beginning, so I'm going to have to do it at the end. I need to factor this guy and pull a 5 out of both of those. So it's 5y minus 2, parentheses 2y minus 3. That is our final answer. You wouldn't get full credit for this, just this one. Okay. All right, I got 2 more examples. Okay. This next one is to check if something's prime. You want to check and make sure that something is actually factorable. Okay, so example number 4, 4r squared minus r plus 7. So we're going to check to even see if this thing can be factored. Okay, well, let's check. Do our A and C thing. A times C, we get 7 times 4, which equals 28. Okay, so we know that all these numbers right here have to be factors of 28. So we know 1 and 28. We know 2 and 14. 3 and 28 don't play nice. 4 and 7. 5, no. 6, no. Okay, so those are factors of 28. Am I missing anything? I don't think so. And they need to add up to this -1 right here. So they need to add up to -1. All right, well then better be equal to positive 28, which means that all of these dudes need to be negative. Because a negative times a negative gives me a positive. All right, so these guys make a -29. These guys make a -16, and these guys make a -11. But you're looking at these saying, well, these are all of our possibilities, and none of them add up to equal -1. So since none of them add up to equal -1, you can't do anything with this. Okay, since the factors A and B, A plus B, not A plus B. The factors of 28, since no factors of 28 add to -1, polynomial is prime. Okay, so on this one, your final answer would be that it's prime. Okay, you can't factor this one. All right. Now, the last one that I wanted to go over is something we talked about yesterday. We didn't talk about it yesterday, but there was a problem where you kind of had to use your quadratic stuff that you learned to answer a real world problem. Well, all of these problems model graphs that we call parabolas. Quadratics model parabolas. Okay, so parabola. Okay, and it's a graph modeled by quadratic equations. Okay, a graph modeled by quadratic equations. Parabolas look like this, or they look like this, and then once you get several classes away from here, sometimes we even do parabolas like this. Okay, but those aren't functions because they don't pass the vertical line test. Okay, so we're going to deal with ones like these. And usually, in our world, this is the picture that shows like a basketball being shot and an arc going up and down. The height goes up and then it goes down. So that's the one we use the most of. In your homework from last night, you dealt with like a rocket being launched. That's what that's modeling. You also dealt with, if you tried number 16, there was a football being punted. Kind of goes along with your science homework that you're doing. You watched an NFL thing that had to do with velocity. Anybody? Yeah? No? Maybe? So we're going to look at, and I'm on page 512 right now. We're going to look at the equation that we use with these things. They only gave you part of the equation last night. Okay, so h equals -16t squared plus vt plus h naught. Okay, not h times 0, h naught. Let's talk about what these things mean. This equation is a quadratic function that's going to model the height of a particle, whatever that particle is. Maybe it's a football, maybe it's a basketball, maybe it's a rocket, who knows. The height of something given a specific time, a specific speed from initial takeoff, and an initial starting point height. Okay, so let's write those things in. Okay, so this is your height given velocity, just write height. Okay, just write final height. Okay, t represents time. V represents velocity. Velocity meaning speed, like how fast you're going, like miles per hour or feet per second or something like that. Okay, speed is the same thing as velocity. And then h sub 0 is the same thing as we call it h naught. And it's basically your starting height. Okay, your starting height. Okay, the football one yesterday for problem number 16 technically should have been using an h naught, because when you punt a football and you kick it, it's actually leaving about like between 2 and 3 feet high above the ground. So we would have put 2 or 3 feet in for this height to account for that lift, or I mean that starting point. Okay, so here's the equation. All of this stuff, the 16, it takes into account gravity. We're not going to go into how they created this equation. You can look that up if you'd like, but it does take into account gravity, because if you just shoot something up in the air, without gravity, it would just keep going. But we have gravity because we live here on Earth. All right, so I'm going to do number 4, where it says physical science. A person throws a ball upward from a 506-foot tall building. Okay, picture's worth 1,000 words, always. So, here's 506 feet. 506 feet tall building. And this person, they throw a ball upward. The ball's height, h in feet, after t seconds is given by the equation, blah, 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 blah. The ball, I'm going to write the blah, blah, blah in a second. The ball lands on a balcony that is 218 feet above the ground. How many seconds was it in the air? Okay, so 200, 500, 200, 218. Looks about right. Okay, so this guy's 218. Okay, so they throw the ball here and it lands, right? All right. So kind of need to have a y-axis or a graph that's going to model this. Okay, so we start off at 506. That's where we start off. And then at 201, 218 is where we're going to end. So again, when you throw something off, it's going to go up and down. Okay? Now, it's going to land right here. Now, really, this parabola goes like this. But if it hits, it's not, let's pretend like it's not going to go through the building. So it does need to stop right here. And where it starts, well, it doesn't start in negative time. So right now, this is time equals 0, and time continues. 1, 2, 3, 4, 5, 6, 7. Time continues this way. Okay, so this is our time axis, and this is our height axis. Okay, now they tell us an equation, and they give us the equation of negative 16t squared negative 16t squared plus 48 t plus 506. Okay, so let's talk about these numbers so that we can see what they are. We have this negative 48. Well, that represents our v, which means that the speed when he threw that ball off of, he threw, right? Not kick. Yeah, person throws a ball upward, and it's 48, its speed is 48, I believe it was feet per second. Yes, feet in seconds. Time is in seconds. Okay, so 48 feet per second, that's how fast this thing's going. It started off at a height of 506 feet. Okay, and then don't forget our negative 16 is what helps us account for gravity and things like that. All right, So now we want to know when the height of this thing is going to be 218. So we're going to take this 218 and plug it into our height. We want to see at what time will all of this be equal to a height or match a height of 218. Okay, so I need the space. 218 is going to go in for our height equals negative 16 t squared plus 48t plus 506. I need a bigger board. Plus 506. Get all of the stuff on one side. Get a zero, zero it out. Get 0 on one side. So I'm going to get this 218 over here, and I can only put it with this, minus 218. This crosses out, and I'm left with a 0 over here. Negative 16 t squared plus 48t. Now 506, just off the top of my head, I don't know that one, and I don't want to mess up. 506 minus 218. We get 288. So plus 288. And we need to factor this. Now what did I say? Get rid of this negative at the beginning. Okay? The negative in front of the t squared is going to give you problems. So let's just see if 16 goes into all these guys. I doubt it does, but it's worth a try. 48 divided by 16 is 3. Okay. 288 divided by 16. Oh man, it works. Okay, so 48 divided by 16 was 3. So I'm going to divide everything by a negative 16 because I can take a negative 16 out of every single one of these. And I'm dividing by a negative because I don't want the negative in front of my t squared. So let's just get rid of it. Divide by negative 16 because 0 divided by a negative is still going to be 0. 0 equals t squared. Oh, that's just nice. Minus 3t minus 288 divided by 16 is 18, negative 18. Okay, so now I have this. This is a lot more doable than all of this business. And it doesn't even have a factor in the front. Well, that's nice. So we have negative 18. Let's see if we can find, well, 1 times a negative 18 is just a negative 18. Okay. And we need to find products that multiply to negative 18. So we have 1 and negative 18. Let's do it over here so that we're not. So we have 1, negative 18, and we're multiplying to get to that, but we're adding to get to a negative 3. Okay, so negative 1 and 18, but we also can do 1 and negative 18. 3 and 6. We could also do 2 and 9, but I kind of already see that 3 and 6 is going to work. So 3 and 6, and if we make the 6 negative and the 3 positive, not the other way around, then 3 times 3 plus a negative 6 gets us our negative 3. So we know that this is our 1. So x plus 3 times x minus 6 equals 0. Why am I using x's? I'm supposed to be using t's. Just a habit. We need t's in here. And remember, when you're writing t's, put a little loop on the bottom so that you don't get them confused with plus signs. So we have these. Now we need to set each one of these equal to 0. So t plus 3 equals 0 minus 3. We get t equals negative 3. So at time negative 3 seconds, this thing is going to be at a height of 218 feet. But we don't want to go backwards in time because negative 3 seconds isn't very helpful. We start at 0 and we continue. We don't go backwards. But the picture of the parabola still goes that way. So right here, this would be at 3 seconds. This would be 3 seconds right here. Whereas right here, that would be this guy. T minus 6 equals 0 plus 6 on both sides. T equals 6. T equals 6. So this would be right here at 6. And that's when our guy lands on that other building 218 feet high in the sky. 6 seconds is our final answer. Seconds. I will be on tomorrow at 9 o'clock. If anybody wants to ask any questions, I will help you out. Follow the link on the assignments. There's a question that you can click on, and it just has a link. You can take that, post it in your put it in your browser, and then just follow the link, and you're there. All right, adios.